Alright, so this is looking at the reaction that we looked at the end of the last video. So you have uranium-235 getting hit with a neutron, and you produce barium-140 and krypton-93, as well as 3 extra neutrons and energy. Okay, so notice that this reaction releases 3 additional neutrons. Okay, those 3 neutrons can actually hit other nuclei. So that will also cause a fission reaction, or can at least, where that nuclei is going to break apart, okay, releasing a whole ton of energy. And then if that reaction also releases more neutrons, they can go on and hit more. And because these reactions generally don't release just one neutron, you can use one neutron to produce thousands of reactions through just a couple of these chain reactions. Okay, so these are called nuclear chain reactions. Okay, and it's a chain reaction because you kick it off with one neutron and then it just continuously builds from there. Okay, so this is an example of that. So you hit your first uranium-235 atom with a single neutron. Okay, but that's going to release 3 more, which can then go on to hit more, like 3 additional atoms of uranium-235, which then will each produce at least 3 more. Okay, if they undergo the same reaction, they can produce 3 more neutrons each. So you can see how this can build pretty quickly. Okay, with just 1 neutron, 2 rounds of the reaction, we now have 9 different neutrons going on to perpetuate this reaction. So to keep it going, keep it moving, and keep reacting this and releasing energy. And this all happens in a fraction of a second. Okay? So if you can imagine this continuing on, even if it's just all doing this one reaction where it's splitting uranium into barium and krypton. Okay? Just this one reaction. Now, of course, it's not just this one reaction. There are a lot of different kind of reactions that can happen, but this is obviously looking at a more simplified version. Okay, so chain reactions can actually be controlled using what are known as control rods that will slow these chain reactions. And this is what's actually used in nuclear power plants. So this is how they slow these chain reactions down so you don't get what's known as critical failure. Okay, where these reactions are just going on completely uncontrolled. They're just going on wherever and creating a lot of energy that doesn't really have anywhere to go but up and out. Okay, and that is nuclear power plant meltdown. Okay, so it's when everything explodes. So if pure uranium-235 or plutonium of a precise mass and shape combined with an explosive are used and the chain reaction is not controlled, you get your nuclear weapon. Okay, so it's actually relatively simple, all right, the whole idea behind this, but it's also shaping that correctly, combining it with the correct explosion or the explosive, timing everything right, knowing how to drop the bomb. So a lot of the extra stuff around this core concept of nuclear fission is a lot more complicated. But the nuclear fission, the actual nuclear reaction that takes place, is relatively simple. Okay? And of course, I love this joke. It just cracks me up. So uranium has got 2 dates for the same dance. So his friend is making fun of him. And good luck getting out of this one. If only you could split yourself in 2, right? And, oh, you know, that's an idea. And then he does, and boom. I just think it's an adorable little comic, but, you know. Anyway, so critical mass with nuclear fission is the minimum amount of a substance that can undergo a fission reaction and also sustain a chain reaction. So it does actually have to be relatively concentrated. Okay, you can't just have, you know, 1 uranium atom and expect a chain reaction out of it. Okay, so the critical mass of uranium-235 isn't actually reached in nature. Okay, it never gets that concentrated, which is why we don't have to worry about just random nuclear fission reactions, chain reactions taking place in nature. Because wouldn't that be something? Just walking through the woods one day and then all of a sudden there's a nuclear explosion. That wouldn't be good. So, nuclear reactors and the basic concepts are also relatively easy to understand. Okay, so you have your nuclear reactor here. You've got your fuel rods, which contain your uranium. You also have your control rods. So the control rods are really there just to absorb or block those neutrons that are coming off of these chain reactions. So it controls how many neutrons are bouncing around inside this reactor core. Okay? And in that way, it can control the number of nuclear reactions taking place to make sure that it doesn't kind of go crazy and just result in an explosion. Okay, so you have the nuclear reactor energy is being released by these nuclear fission reactions. Okay, that's going to heat water in a high pressure first circuit. So in this first circuit, it's still going to be water. It doesn't actually, it's under too much pressure to allow it to create steam. Okay, but that will actually go through this water reservoir. Now this water reservoir doesn't have any constraints on it pressure-wise. So when it hits this, basically this tube with the high temperature water, it's going to immediately become steam. Okay, so that's right here. And so it flashes into high pressure steam, which then is directed into this third area here against the turbine, which sets it into motion. It starts spinning it, which will generate electricity. Okay, that steam is then allowed to condense and is cooled into water. Okay, so the waste heat will actually get released from the cooling towers, which are these giant towers that you'll see. If you saw that X-Men movie, whatever it was, with the horrible Deadpool, okay, the fight between Deadpool and then Wolverine and Sabretooth actually takes place on top of a cooling tower. Okay, that's what they destroy when he falls. Yeah, if you know the movie, you understand what I'm talking about. Anyway, so the waste heat is released from that cooling tower. Okay, so it's released in the form of steam. And then the water that was allowed to cool, okay, and release that heat, then pulls back down and can get pumped back into this water reservoir to get heated again. So it's a constant cycle of cooling and heating and turning the turbine and so on and so forth. Okay, but that's how they actually extract energy from this. Now, these fuel rods, okay, in the reactor core here, eventually they will not be able to support a continued reaction, okay, the continued nuclear reaction, fission reactions. So at that point, they are considered used fuel rods. They are still radioactive, though, unfortunately, which means that they have to be stored very carefully for, well, as long as it takes for them to no longer be radioactive. Okay, so there are storage facilities with these used fuel rods that are just kind of waiting for their half-lives to pass. Okay, which is going to take forever, but anyway, safer than just kind of dumping it randomly out in the wilderness. So, usually those are underground. They are sometimes lead-lined. If they're actually being really safety conscious, they are lead-lined. So on and so forth. Okay? Okay. When you talk about nuclear fission and power plants, you always have to talk about the worst power plant failure to ever take place. So it actually happened at the Chernobyl nuclear power plant in Pripyat, Ukraine, in the former USSR. Okay. So this is an image of the reactor, the power plant. Okay. It had a meltdown. It was not a full nuclear explosion, but it was a meltdown that caused a lot of damage to the surrounding area. It took place on April 26, 1986. HBO actually did a show recently about Chernobyl and what led to the disaster. Russia apparently was unhappy with the production and has since decided to produce their own. Yeah, no word as to how good that is or how weird it is. Anyway, 31 people were actually killed at the time, and most of that was actually due to rubble falling in the building destruction. There wasn't a whole lot of actual like explosion that killed people or, you know, radiation poisoning immediately, because radiation poisoning does take a while to work on humans. So that radiation poisoning has actually been the cause of several more deaths since. It's kind of, I mean, when you think about what country it took place in, the time when it took place, it makes more sense as to kind of how the government reacted to it. But they pretty much told everybody in town, oh, you know, it's fine. That gray dust falling from the sky, yeah, you don't need to worry about that. Just keep going to school, you know, keep going along with your life. So the ironic part of the nuclear power plant failure is that it occurred during a late night safety test, which was actually simulating a station blackout power failure. Okay, so trying to see if they could actually respond to a certain situation. And so they had turned off the safety systems intentionally for this test, which obviously kind of turned around and really screwed them over with this. Okay, so, and there were a lot of signs they saw that just got completely ignored. So this really didn't have to happen, except there were people in charge who didn't really know what they were doing, just kind of were pretending that they knew what they were doing, and weren't listening to the people who actually knew what they were doing, and hence the destruction that took place. What is kind of strange now is that Chernobyl has become something of a tourist destination. Now, there are certain regions that you still cannot go into because it is still radioactive to this day. And if you go on one of those trips, you do have to wear a Geiger counter, okay? Just to make sure that you're not walking into a radiation area where it's unsafe levels of radiation. But the people who have gone on these trips, the pictures that they've taken, the drone video they've taken, it's kind of eerie because everything, when they decided to evacuate the town, everybody just left, and they left everything the way it was. So there are images from like a schoolhouse where there are still desks there, and there are like dolls and things like that on the floor, and it's all covered in dust by this point, because, I mean, it happened in 1986, and it's still just sitting there. So it's kind of eerie to look at. But I posted one of those videos so you can see what it looks like now. But anyway, so that is it for this section.